Figure 6.5, Promotion Hierarchy for Fundamental Data Types. In C++, when you have expressions that use multiple different types of data from the fundamental data types, which are listed here in Figure 6.5, you're going to automatically get certain promotions as part of those calculations. Now, the promotion hierarchy that you see here lists the data types in descending order, basically. So a type lower in the list can be converted to any of the types higher in the list. So as you can see here, for example, all of the integral types can be converted to float, double, or long double, which are the floating point types. On the other hand, a floating point number cannot be converted automatically down to any of these other types because that would result in the loss of data in most cases. And in C++, it will typically give you a compilation error if you try to convert an argument or a value of one of these higher types to one of the lower types in the list. And this can come into play in a number of different scenarios. It can happen certainly in a mixed type arithmetic expression, in which case all of the values within the expression will be converted to the highest type in the expression. So for example, if I have an int and a double, the int will be promoted or coerced, if you will, into type double. Then you'll have a double calculation. And similarly, if you have a long and a double, the long would be converted to a double, etc. By the way, notice that long int is synonymous with long, and you see some synonyms for several of the other integral types as well. Another case where you could get these promotions is when passing arguments to a function. So for example, if you have a function that expects to receive a double, it can technically receive a value of any of these lower types in the table. Similarly, a function that expects to receive an int can only receive int and lower types in the table. If you try to pass in a value of a higher type, you will get a compilation error in C++. In C, typically you'll just get a warning indicating that there might be a loss of data. So this is one of the differences with respect to data type conversions, or implicit data type conversions, I should say, in C++. You can always perform an explicit data type conversion in C++ using the static _ cast operator, which we discussed in an earlier lesson. Figure 6.10, Simulating the Dice Game Craps. In this program, we're going to write a simulation of the casino game called Craps, in which the user rolls 2 dice. And on the first roll of those 2 dice, if the user or the player rolls a 7 or an 11, they win. If they roll a 2, a 3, or a 12, they lose. And any other value is that player's point, and the player must roll that value before rolling a 7 in order to win the game. If they roll a 7 on a second or subsequent roll, they lose the game. And I've already executed this program 4 times to show you some of the common cases. So here we have a case where the player rolled a 7 on the first roll, so the player won. In this next one, we have a case where the player rolled a 4 on the first roll, so the point is 4 because they didn't roll 7, 11, 2, 3, or 12. And then we went through a series of subsequent rolls, none of which were 7s, and eventually we rolled a 4 again, so we won the game. This next case is a loss on the first roll because the player rolled a 2. And the last case here, we show you the player rolling an 8, which is their point, rolling several subsequent times, and then rolling a 7 before rolling an 8, and therefore losing the game. So basically, we've implemented this game in Figure 6.10, and we're taking advantage of a couple of features that we haven't looked at before. If you're coming from the C programming language, you may already be familiar with the rand and srand functions. They're in the C standard library header called stdlib.h. In C++, all of the C standard library headers have been renamed to remove the .h and to start with the letter C. So for example, down at line 11 here, this is the old C programming language time.h header file renamed for C++ to be ctime. And the difference between the C++ versions of these headers and the C versions is that all of the functions that are defined and declared in these headers are part of the standard C++ namespace. So in order to use them properly in our code, we have to have a using declaration that specifies either the explicit functions we intend to use with std : and the function name, or we have to have a using namespace std statement like we discussed back in the earlier lessons. So we're going to use rand to generate random numbers, srand to seed the random number generator, and time will be used to help us also with seeding the random number generator. Basically, we want to make sure that the pseudo-random numbers produced by rand change sequence every time we execute the program, and the best way to do that is by passing to srand a value that's constantly changing every time you run the program, and of course the time of day is constantly changing. We also have a roll dice function in this example, and the example is nice just because it shows you a lot of the different control statements that we've been looking at so far. It also gives us a chance to have our own separate function being called directly by main. In prior programs, we've certainly called functions from main, but they've been member functions of an object of a class, such as gradebook, not separate, standalone, globally accessible functions, and that's what roll dice is in this example. Now, in the main function is where we implement the logic of the craps game simulation. The first thing we've got here in main is a new data type called status, which is an enum data type. Enum stands for enumeration, and it's used to create named constants in C++. The syntax is the enum keyword followed by the type name, a set of curly braces that delimit a list of named constants, and a semicolon to terminate the new type. By definition in C++, the first constant in the list gets the value 0 by default, and each subsequent constant gets 1 plus the previous constant in the list. So 1 will be 1, lost will be 2, etc. You can also explicitly assign values to the named constants by providing an equal sign and a value. So if I do that, then the value of 1 is 1 plus the value of continue. So now you can see 1 is 2 and lost is 3. So you can explicitly assign values. The values don't need to be unique, by the way. You could explicitly assign a value to every constant in the enumeration. However, the names of those constants must be unique for use in your program. And once you create this new data type, you can then declare variables of the type, and the values of those variables can only be the values that are listed in the enumeration. Now, for the purpose of the game, we've declared an integer called myPoint, where if the user does not win or lose on the first roll, we'll store their point so that we know what we need to roll to win the game in the future. We've also declared a variable of type status called gameStatus, which we'll use to store continue, won, or lost based on the status of the game at any time. Now, when you're going to do simulations using random number generation, once in your program you'll want to execute the srand statement like the one on line 25, and srand receives as its argument an unsigned integer value, and time gives us the time of day. And basically what we're doing is using the time of day to seed the random number generator.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.